All right, good afternoon, everybody. So my name is Juan Carlos Peña, Jr., and I'm one of the meteorologists here on staff in the National Weather Service Corpus Christi office. So today we will have the Wednesday webinar about hurricanes. So hopefully it's informative and you guys enjoy. And if you have any questions at the end, just please feel free to let me know. All right, so here's just an outline of what we will be covering today. So pretty much when is hurricane season, when is the peak of hurricane season, and where do they typically develop, definitions of related to hurricanes and tropical weather, as well as the Saffir-Simpson wind scale. We'll also discuss hurricane structure, as well as the different sizes of hurricanes and the different improvements that we've had with satellites over the years. We'll also discuss storm surge and preparedness. We know what you should know and what we should do now before hurricane season to prepare. So hurricane season, the official hurricane season for the Atlantic Basin, which consists of the Atlantic Ocean, Caribbean Sea, and the Gulf of Mexico, runs from June 1st through November 30th. However, that doesn't mean that tropical systems can't form at any other time of the year. Although not likely due to unfavorable conditions, tropical systems can form outside of hurricane season. Within the last 20 years, we've seen tropical systems form as early as May, and some form as late as December. And actually, the past couple years, we've actually had a couple systems that have formed in the month of May, not having completely tropical characteristics, but they have been tropical systems. Now, as you can see here on the graph, the peak of the hurricane season in the Atlantic Basin is actually September 9th. But I don't want you to focus on an exact date, because as you can see, the peak of the activity is from mid-August to late October. That's the most active period of the season. That's when we have the most storms develop, and usually the most amount of storms out in the Atlantic that the Hurricane Center is monitoring. However, destructive and deadly hurricanes can occur at any time during a hurricane season. So even if we are in early June or July, and typically there may not be a lot of systems, that doesn't mean that a dangerous system can occur. So although tropical storms and hurricanes can develop anywhere across the Atlantic Basin, the most likely areas in June are across the Gulf of Mexico, Western Caribbean, and along the east coast on the Atlantic Ocean. The white lines in this image signify the prevailing tracks for possible systems and which direction they are most likely to travel. So as you can see, for the month of June and for the following few months to follow, hurricanes that develop during these months can enter the Gulf of Mexico and possibly even affect Texas. So here is the image for July, and just like in June or July, not many systems form in the Atlantic as the water temperatures aren't necessarily warm enough, and conditions usually are not favorable due to strong upper and mid-level winds, which we'll talk about later, known as wind shear. So usually the systems tend to form closer to the United States and the Gulf of Mexico and the Caribbean. As you can see, even in July, there is a possibility for systems to affect Texas and the Gulf Coast. So this is for the month of August, and as August comes along, not only are tropical systems more frequent, but they also develop further east. So now you can see the orange box, how it extends to the Eastern Caribbean and the Western Atlantic Ocean, as now the tropical storms and hurricanes tend to form further and further away from the United States. As September comes around, with being the peak of hurricane season, tropical systems are possible anywhere across the Atlantic Basin. So as you can see in the image, tropical systems are likely to develop from anywhere from the Gulf of Mexico all the way to the Eastern Atlantic Ocean, and have many different routes that they can take. This is usually when systems will start to form as soon as they come off of Africa, and this is the time where we usually have about a week to monitor and 7 days before they affect land. So this is a time where we have a lot of sitting around and waiting and monitoring the advisories from the Hurricane Center and the forecast track. But just because they could form all the way on the Atlantic doesn't mean that we could have one that forms maybe in the Gulf a lot closer to home, which means we'll have less time to prepare and less time to monitor. So usually anywhere from August and September, we really want to be paying attention to the tropics every day, just making sure that there's no system out there that could possibly affect us. And if there is, just make sure that we prepare for it. So as October comes around, the water temperatures across the Atlantic begin to cool down and conditions become less favorable for development, with the most likely areas being the Western Caribbean, Western Atlantic Ocean, and the Gulf of Mexico. And as October comes around, cold fronts will start making their way across the central United States, and that will actually pick up the hurricanes and tropical storms and steer them more towards the Atlantic, and typically away from Texas. And that's just a product of the late season with the cold fronts coming through, as the cold fronts tend to steer the systems away from the United States. So here is November, and once again in November you can see that the track being more towards the Atlantic Ocean, and that's due to the cold fronts that continue to make their way through the United States and actually reach the southeastern portions of the United States, which create not only the favorable track and influence to take them out to sea, but it also creates high winds, which is wind shear, which typically destroys systems that try to develop and will make them unfavorable. Furthermore, any system that does develop is usually picked up by the cold fronts and steered away. So here are just some definitions of tropical systems. So the first thing would be, what is a tropical wave? Well, a tropical wave is an area of disturbed weather with curvature or cyclonic spin across the Atlantic Ocean. Tropical depressions are the weakest in the early stages of tropical systems. Once a tropical wave has a closed center of circulation and sustained winds of 30 miles per hour, it will be upgraded to a tropical depression. However, it will be given a number instead of a name. It is not until the system strengthens and sustained winds reach 39 miles per hour that a name is given, as it becomes a tropical storm. Once sustained winds reach 74 miles per hour or greater, the system will then be considered a hurricane. And when the winds reach 111 miles per hour or greater, it will be considered a major hurricane. Wind shear is the difference in wind speed or direction over a relatively short distance across the atmosphere. You will tend to hear a lot about wind shear breaking down hurricanes, as the stronger winds that will blow the thunderstorms to one side or another and prevent the hurricanes from becoming better organized and symmetrical, thus not allowing the hurricanes to strengthen. So usually when you'll see that is when a hurricane is trying to become circular like the one on the screen, but the winds might be blowing out of the southwest, and it might be pushing the thunderstorms to one side or another. And usually when that happens, that usually tends to weaken the system and prevent the system from strengthening. So next we'll cover the Saffir-Simpson hurricane wind scale. And once a tropical storm strengthens into a hurricane, they're categorized into 5 groups, which show how strong they are and what kind of damage can be caused. When a hurricane has sustained winds of 74 to 95 miles per hour, it is considered a Category 1 hurricane. With a Category 1 hurricane, you can expect very dangerous winds, which can produce damage. A Category 2 hurricane has sustained winds of 96 to 110 miles per hour, which are extremely dangerous winds that will cause extensive damage. Winds between 111 and 129 miles per hour signify a Category 3 hurricane, which is when a hurricane is considered a major hurricane and can cause devastating damage. Category 4 hurricanes have winds between 130 and 156 miles per hour, and Category 5 hurricanes have winds of 157 miles per hour or greater. With a Category 4 or 5 hurricane, you can expect damage to be catastrophic. The Saffir-Simpson wind scale was developed by a wind engineer named Herb Saffir and a meteorologist, Bob Simpson. Bob Simpson, who was originally from Corpus Christi, was actually a survivor of one of the deadly and costly hurricanes in 1919 that made landfall over the coastal bend, and who later went on to become the director of the Hurricane Center from 1968 to 1974. So next we'll see an image, and this is a video of the different type of damage that a hurricane can cause. So as you can see now, it's Category 1 winds, and the trees will start to bend, and some debris will start flying around. As Category 2 winds come across, it starts to create more damage. And as the winds get stronger with Category 3 and above, you can see just how much damage can be created with these winds. All right, so next is, what is the difference between a hurricane watch and a warning? Well, hurricane watch is typically issued when tropical storm force winds are possible within 48 hours. A hurricane warning is issued when tropical storm force winds are expected to affect the area within 36 hours. When a watch or warning is issued, advisories will be issued every 3 hours from the National Hurricane Center, while the forecast track, which is the cone, will be updated every 6 hours. If there are no watches or warnings, advisories are then issued every 6 hours. Now this is a graph with the Texas hurricane landfalls by month, and as we can see, tropical storms and hurricanes can impact and make landfall over Texas as early as June, which is technically the first month of hurricane season. However, climatologically speaking, August and September are the most active months with landfalls across Texas. So this is another chart showing the hurricane landfalls. So the previous one was tropical storms and hurricanes. This one looks at only hurricanes. And as we can see, a hurricane typically makes landfall in Texas during the months of August and September, as well as some in June. However, that doesn't mean that hurricanes can't make landfall in every other month. It's just those are the months where they occur the most. So this is a graph of major hurricanes that make landfall by different months across Texas. And as you can see, of those hurricanes that actually reach major hurricane status, which was 111 miles per hour or greater, they're most likely to make landfall during August and September. Next, we'll discuss the different structures of the hurricane, their stages, and their developments. So one of the initial developments is showers and thunderstorms that develop along the intertropical convergence zones, which a lot of times is abbreviated with ITCZ. And that is where the trade winds from the southern hemisphere and the northern hemisphere meet and usually cause a good amount of showers and thunderstorms. This activity, if the conditions are right as far as the warm sea surface temperatures and the low wind shear that we talked about earlier, can result in the development of a tropical wave and even possibly a tropical depression. Now, tropical systems don't depend solely on the intertropical convergence zone as a source of their energy in showers and thunderstorms. Hurricanes can also develop from showers and thunderstorms associated with old tropical systems that have weakened, or even cold fronts that might stall and produce an area of showers and thunderstorms across the Gulf and the Atlantic Ocean. As a matter of fact, right now, the National Hurricane Center is monitoring an area just off the coast of the Bahamas from a cold front that stalled, and there's an area there that might develop into a tropical depression, and that area should move off to sea, so there's nothing to concern us about. But that's just an example of systems that could develop, from just old tropical systems or a stalled cold front. So as far as how a hurricane forms and the formation of them, it starts with the tropical disturbance. And a tropical disturbance is a cluster of thunderstorms that develop in an area where sea surface temperatures are above 78 degrees. And pretty much these groups of thunderstorms or cluster of thunderstorms will go ahead and push warm air upwards. And as the thunderstorms grow bigger and start to merge and combine, the surface pressure will begin to drop. Once the depression becomes more organized and gets on more of an organized and circular shape, wind speeds typically will become faster with heavier rain, and the surface pressure will begin to fall. Once a tropical storm becomes better organized and more thunderstorms around the center of circulation, sustained winds will continue to pick up and get faster, and the surface pressure will continue to fall, which will lead to the formation of a hurricane. When a tropical system is organized and the hurricane continues to strengthen, it will form a relatively cloud-free zone, which is called the eye. And the eye typically appears in the center of the hurricane, and it is surrounded by the different rain bands that go and spiral into the system. So a tropical depression, once again, will form when an area of thunderstorms develops a closed center of circulation and becomes more organized with a circular shape. At this point, the hurricane hunters will start to fly missions into the system, which are known and called reconnaissance flights. And these hurricane hunters do the reconnaissance flights, and they fly into the hurricane for hours at a time to gather data for the National Hurricane Center. And the National Hurricane Center will grab that data and put it into their computer models, as well as use the data to issue hurricane advisories and do their forecast track. Now, the only exception to when hurricane hunter will not fly into a system, into a tropical storm or hurricane, would be when the system is too far east across the Atlantic Ocean. At that point, the hurricane specialist at the Hurricane Center will use satellites, as far as with also several techniques to determine the strength and the wind speed of the system. Once a tropical depression gets better organized, more stronger thunderstorms will begin to form and wrap around the center of circulation, and sustained winds will increase. Once they increase to 39 miles per hour, the tropical storm will be formed. At this point, rain bands with heavy rains will begin to spiral in across the center and begin to wrap around the center, and the system will become more circular with clouds reaching the upper levels. Now, often the tropical storms do have clouds in the center, but often those clouds are rain-free, as rain is not occurring in the center of the system. Now, tropical storms usually don't have an eye like hurricanes do, and that is pretty much because they aren't as well organized yet, and the surface pressure is still too high, so it doesn't have the sinking air due to the lower pressure to help develop the eye. So once a tropical storm enters favorable conditions, such as warmer waters and the absence of the wind shear, a tropical storm can then strengthen and become better organized and form into a hurricane. At this point, the spiral rain bands become better defined and more evident, as well as the presence of an eye and eye wall. An eye wall would be the innermost rain band or ring that rotates around the center of circulation. The eye wall is where the most intense convection and thunderstorms will be found, as well as the strongest winds that the hurricane hunters are able to find, which are what comes out reported in the advisories. Once a tropical system becomes a hurricane, they will get better organized, more circular in appearance, and usually have an eye. So an eye forms once the hurricane becomes well organized and is gaining strength. The presence of an eye is a good indication that a hurricane is strengthening and is usually associated with major hurricanes. So around the eye is the eye wall, where is the most intense weather within a hurricane. At the surface, the rain bands will spiral into the eye and create an inflow, which will then rise upward within the eye wall. Once it reaches the top, some of that energy will begin to rise and spread out as outflow, or sink back down to the surface. Now, once the air starts to sink back down to the surface, it will go ahead and start lowering the pressure. Now, the more intense the hurricane, the more intense this cycle will be, thus a much lower central pressure will be developed. Therefore, winds are used to determine strength with the Saffir-Simpson hurricane wind scale, and a lot of times hurricane central pressure will tell us just how strong a hurricane is and if it's getting stronger or weaker. So although the winds are very important, sometimes the central pressure could be just as important, as it will let us know just how strong the hurricane is, especially once it reaches Category 5 status. That there is no more categories for the hurricane to continue going, but the central pressure will tell us just how strong the hurricane is. So within a hurricane, everything starts with showers and thunderstorms away from the hurricane that wrap around the center, which creates the inflow. The rain spirals into the center as rain bands, not a constant large thunderstorm. The reason behind this, as seen in the image above, is the energy and moisture rises with rain bands, and once it reaches the top, it meets the dense cirrus overcast and sinks back down to the surface. As that energy subsides to the surface, it inhibits the development of new showers and thunderstorms, which is why you get the waves of rain bands and not a constant large thunderstorm. As the rain bands get closer to the center, they become more intense and grow in size. When the rain band finally reaches the center of the eye wall, that energy rises through the eye wall, and the outflow creates that thick, white, dense circular cloud that we see on satellite images called the cirrus dense overcast. Now, hurricanes can vary in sizes. As you can see, hurricanes could be large or small. Now, just because a hurricane is large or small does not mean that one is more powerful than the other. The images above are from two powerful hurricanes, Hurricane Floyd in 1999 on the left-hand side, which was a large hurricane, and Hurricane Andrew in 1992, which was a strong but compact hurricane, which is the one on the right. Despite Hurricane Andrew being almost half the size of Floyd, it was just as strong and powerful, creating plenty of damage across South Florida and the Gulf Coast. Both were extremely dangerous and powerful Category 5 hurricanes. Over the years, with improvements in technology, satellite imagery has become tremendously better. On the top left corner is a radar image of Hurricane Carla. Back then, there was no color to signify heavy showers, and the resolution was not very good. In 1992, with Hurricane Andrew, the resolution still wasn't perfect. However, at least the color helped showing the different intensities of the thunderstorms. In 2018, we can see just how great satellites have gotten. We can now not only see how intense the thunderstorms are with the color, but the resolution is also fine enough that we can see different thunderstorms developing and weakening as they spiral into the center of the hurricane. Now, this chart will show the different amounts of deaths associated with hurricanes from 1963 through 2012. As we can see here, almost 50% were due to storm surge, and over 80% were due to water. Amazingly enough, wind only causes less than 10% of all deaths within a hurricane. So the water is definitely the most dangerous part of the hurricane. Although winds are important because winds can cause a lot of damage, the water is really the most deadly part of a hurricane, not necessarily the winds. So what is storm surge? Well, as a hurricane moves towards the coast, it will push a dome of water, and that will cause an abnormal rise in sea level towards the coast. Most of the storm surge is actually wind-driven, with only 5% of the storm surge being created by the pressure. There are several variables that will lead to the size, to the amount of storm surge, such as the size of the storm, the size of the wind field, the intensity of the winds, and the type of ocean floor along the coast. As the hurricane makes landfall, the dome of water will approach the coast, and that will make the water pile up depending on the ocean floor. It'll start to pile the water up, and once it starts to pile that water up and push on to the shore, it is creating the storm surge. So this is an example of how storm surge will affect the coastal areas. As waters pile over the taller waves pile over the shorter waves that have already made it on shore, the water will begin to further come further inland. Now, depending on the intensity of the hurricane, storm surge can become high enough to destroy and possibly even wash away homes, as well as flood neighborhoods. That's why it is very important to heed official evacuation orders, especially if near the coast where you'll be vulnerable to storm surge. So the previous video is only from categories 1 to 3. Now the next slide will show how storm surge will look in category 3, 4, and even 5 hurricanes. So as you can see, the stronger the hurricane will have the stronger winds, and then as depending on the size of the hurricanes, as hurricanes become larger, that will have the larger wind field, and that will push more water, more winds towards the coast, and could even potentially get to category 4, category 5. And as you can see at that point, there is enough water coming on shore which will create plenty of damage combined with the winds. So as mentioned previously, water can be just as devastating as winds. And these images are from a tropical wave that didn't have strong winds and it didn't have a name. The tropical wave resulted in so much rainfall that several cities across the coastal bend flooded, and it actually caused more than $25 million in damage. So the National Hurricane Center is located in Miami, Florida, and they are responsible for tropical activity in the Atlantic Basin and the Eastern Pacific Basin. All advisories, forecasts, and watches and warnings are issued from the National Hurricane Center in collaboration with the local weather forecast office. And the current director of the Hurricane Center is Ken Graham. The National Hurricane Center is open 24 hours a day, 365 days a year, and apart from advisories, forecasts, and watches and warnings, they also conduct live media and social media broadcasts during hurricane season and during hurricanes. The office is comprised of 10 hurricane specialists, a warning coordination meteorologist, a storm surge unit, and the director of the National Hurricane Center. Now, there's plenty of places to get information about hurricanes. The official website of the National Hurricane Center is www.hurricanes.gov. And on this website is where you can find information from advisories to watches and warnings, and even discussions and reasoning as per why the hurricane specialist is forecasting what they're forecasting. So if you're ever curious on to want to know, why did they choose a specific track, or why did they have a specific intensity, there is a discussion portion on that website which will give you that information. Although sometimes it will be pretty technical. So if you do have any questions, you can always reach out to your local office, and we can always try to help you out with that. So now, one of the products that they issue is the Hurricane Forecast Track. Now, a lot of people have a lot of misconceptions with the track. The Hurricane Forecast Track represents the probable track of the center of the tropical system. On average, the center of the tropical system will stay within the track 2/3 of the time, or about 67% of the time. And it will only travel outside of the cone 1/3 of the time, so only 33% of the time. So the forecast cone is not an impact cone, as impacts can occur outside of the cone, depending on the size of the hurricane and the strength of the hurricane. Impacts will usually arrive before the system makes landfall, and the cone will continue to narrow as landfall approaches due to decreasing official errors in the track. Now, every year, the National Hurricane Center gets more accurate as the track errors reduce each year. This is a result of better observations, better modeling, faster computers that allow us to run multiple models, and a better understanding of the atmosphere. In the 1980s, the average error for a 3-day forecast, which is about 72 hours in the future, was about 350 miles, which is just about the size, the distance from here to Dallas. So that's a big distance, for a big gap for error. In the 2000s, we were able to reduce the error to only 150 miles, which is about the distance from Corpus Christi to San Antonio. That's a big improvement. Now, most recently, as per 2018, the average error has dropped all the way to roughly about 80 miles, which is the distance between Corpus Christi and Victoria. So each and every year, the National Hurricane Center improves their forecast. As they improve the forecast cone, will continue to shrink. Now, as you can also see, the intensity has also improved as well. So a few years ago in the 2000s, the intensity used to have a large margin of error, and as the hurricane models get better, and not only does the track error reduce, but also the intensity error is reduced. So we're understanding the atmosphere better. We're getting having faster computers, which allows us to do more model runs, and that pretty much really allows us to reduce the amount of errors not only with the track, but with the intensity of the systems. We also have our local tropical webpage, where you can find any and all information that the National Hurricane Center has that pertains to our local area. So here we'll post updates from all the way from advisories to forecast tracks to discussions, and everything that is relevant to Corpus Christi we will have on this webpage, and that is weather.gov/Corpus Christi. Social media is another way that information and alerts are delivered. With social media, we can post hurricane advisories information, videos before, during, as well as videos of our balloon launch, which gather information for the National Hurricane Center and goes into models that allow the hurricane specialists to do their forecast. And this is just a video of one of our balloon launches and during one of the hurricanes. This is actually before Hurricane Harvey, which we collected the data, and that data that we collected helped the hurricane specialists at the Hurricane Center develop a more accurate track and develop a better understanding of the atmosphere around the hurricane. So as you can see, the balloon is quite large, and it is very windy. So it's very hard to control the balloon. So that's why you need two people. One person who releases the balloon, and the other person who will run with a device to make sure that it doesn't hit any obstacles. And that balloon will go about 30 to 60,000 feet in the air, sometimes even higher depending on how strong the hurricane is. And that will collect valuable data such as wind speed, pressure, temperature, and all that data goes directly to the Hurricane Center. Now, we're not the only office that does those balloon launches. There are 122 offices nationwide, and usually when a hurricane is approaching the East Coast and the Gulf of Mexico, the Hurricane Center will have all the offices from Texas all the way towards the East Coast launch special balloons. So instead of doing 2 balloons a day that we normally do, we'll actually launch 2 other specials balloons. So that's a total of 4 balloons per day with about 50 offices. And all that data goes into our computer models and pretty much allows us to understand the atmosphere and the conditions not only within the hurricane but around the hurricane. So for example, if we have an office in Oklahoma that's doing a special balloon release, that's really important to the Hurricane Center because we might want to know if there's a cold front approaching, how strong is the cold front, and will that front affect the track of the system. So the balloon launches are very important, especially the special release and the special balloon launches for the Hurricane Center. So another way to find out what's going on with tropical systems is our weather video briefings, and you can find these video weather briefings on our webpage at weather.gov/CRP. And once you go to our webpage, it's towards the bottom, and it's labeled Video Briefing. And this video gets updated 4 times a day when watches and warnings are issued. And they're also posted on YouTube and Facebook. So now is the time to get prepared. As history shows us, tropical systems can affect Texas as early as June. So pretty much how to get prepared, we just want to make sure that all the garbage is picked up, trees are picked up around the house, because that's all stuff that if a hurricane does hit, can all become flying debris and cause damage and possibly even hurt someone if they're out during the storm, or if the firefighters or ambulance need to get to someone as an emergency. any garbage or trees or stuff that's not picked up before the hurricane comes will turn into debris and flying projectiles that could cause injuries, not only to people, but could cause damage to houses and other buildings. So there are many ways to prepare for hurricane season. And one of the most important ways to prepare would be to go shopping before hurricane season to get your supplies and go down your checklist. So you want to make sure that you have 7 days of water per person per day, as well as non-perishable canned foods. So those are canned foods that won't go bad, such as tuna and other foods like that. Battery-powered radios and flashlights, as well as first aid kits, are also very important during and after the storm, as you don't know when power will return. So if you're without power for a few days, you want to make sure you have enough batteries for your flashlight and your radio to be able to know what's going on and be able to see after the sun sets. So the best thing to do is to make sure that your checklist is done prior to hurricane season. Now, knowing your evacuation route in case you need to leave is also a very important thing to do, because having a plan and knowing the route ahead of time will save you a lot of time that you might need if in the event that you need to evacuate, if you had a system that was approaching. So the bottom line is that now is the time to prepare. With a couple weeks before the official and technical start of hurricane season, now is the time that you want to go down your checklist and prepare for any system that might affect South Texas and the Gulf Coast. So waiting until the storm is approaching is never a good idea. It doesn't matter if we have an active season with plenty of hurricanes or a slow season with only a few. It only takes one hurricane to affect an area and wreak havoc. So being prepared is the best way to ride out and possibly survive the storm. So once again, now's the time to get prepared, and being prepared is the building blocks and the foundation of having a good plan. So thank you for watching, and that is the presentation. If you have any questions, please feel free to ask them now.